Okay, we're asked to use the six-step process to graph the function f of x is equal to x over 1 plus x squared. Okay, so the first part of this process is to take this guy right here and look for any symmetry. So the symmetry, well, let's take a look at f of negative x. That would be negative x over 1 plus x squared. And negative f of x would also be negative x over 1 plus x squared. So these guys are equal to each other, and that means that the function's odd. And so that's going to give us symmetry along the origin. So point symmetry. Okay, question part 2 is we need to look for any issues where the denominator is 0. Well, that's not the case here, because the only way to make this guy 0 is for this guy to be negative, and that's clearly not possible. So no asymptotes vertically. Okay. Now what about horizontal asymptotes? Well, of course, there are horizontal asymptotes because we have end behavior for the function. So the question is, what is the limit as x approaches positive infinity of f of x? Now, what we can look at here is that the denominator's power is higher than the numerator's power. And so since that's the case, this is going to be equal to 0, because this guy will grow faster than this guy will. Okay. Another way of looking at it would be to take this function on the inside and rewrite it as 1 over x plus x. And again, this as x goes to infinity becomes 1 over 0 plus an extremely large number. So that's going to go, as we do this, it's going to go towards 0. So what we know is that as we approach out in this direction, we go towards 0. Now the question is, do we come from the top or the bottom? Well, way out here, my numerator is positive, my denominator is positive, so I must be coming in from the top. Now let's look at the limit as x approaches negative infinity of f of x. Same story applies here. We get 0 out. This guy goes to negative 0. Well, we can think about it like, I shouldn't say negative 0. That's a bad way of saying it. What I should say is that the numerator goes to 1. Same story here. Denominator goes to 0 here. This guy goes towards negative infinity, and you take 1 divided by a really, really large negative number, it's still 0. But over here on this side, the numerator is negative, the denominator is positive. So we're going to come out from the bottom because a negative over a positive is negative. So we've got our two guys stretching in that way. No vertical asymptotes. And symmetry is involved, so this makes sense. If we're coming up from down here, then we've got to be coming this way from down here on this side. Okay. Now, part 3 asks us to start looking at the critical points. So I'm just cycling back to see the steps that the author wants you to use. And it says locate minimums, maximums. Okay, so part 3. Well, let's take a look at f prime of x. Well, that's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So this will become 1 plus x squared minus 2x squared over 1 plus x squared squared. And so this will become 1 minus x squared over 1 plus x squared squared, just like that. Okay. And so now what we want to do with this guy right here is we want to check to see, well, first, when is it 0? Okay, so let's go ahead and play around with that guy. Okay. So when is this guy 0? Well, denominator doesn't matter. The only thing that can make a fraction 0 is the numerator. So the only guys that can be plugged into the numerator are -1 and 1. So when x is equal to -1 or 1, we have a situation where we may likely have minimums and maximums. Although, we should be careful. We should check the second derivative with those as well. Okay. So to go ahead and check the sign, okay, we'll look at f double prime of x, and f double prime at x, okay, is, oh, and another thing I should mention here too. To see where the function is increasing versus decreasing when it's headed up and when it's headed down, well, we'll look at the endpoints of these intervals. So what we have is we've got negative infinity. When I say endpoints, I just mean we'll look at these portions here. So we'll look at this guy, we'll look at -1 to 1, and then we'll also look at 1 to infinity. So on this interval right here, the first derivative, okay, these guys, anytime I square the negative, it's more than this, this guy will be more than this guy. So the top will be negative, the bottom's always positive. So this f prime of x is negative, which means that our tangent lines are negative, so we're headed down. So here's the value -1, here's the value 1, and so on this interval, we're headed downward. Okay. Now, as we check between -1 and 1, these guys will all make this thing positive, so we must be increasing. So f prime of x is greater than 0. So we're increasing on this interval. Okay? And now this interval back here, again, this is going to be more than this, so we must be decreasing, like that. So we've got, let's just make sure that these are actually mins and maxes, so we can take a look at f double prime. Oh, by the way, so we just said that this f prime of x, this guy, is negative, which means we're heading back down like that. Now, it looks like we've got mins and maxes probably, but who knows, maybe it's some kind of weird inflection point or something, so let's just check. So f double prime of x is the derivative of this ugly mess. And I'm not going to work through the whole thing, but when you do work it out, you get the following. Like that. Okay? Now, when we take 1 and plug it in, we get 2 times something that's not 0. So this is clearly not 0. And when we plug in -1, we get -2 times something that's not 0. So this is clearly not 0. So f double prime of x evaluated at these two guys is not 0, which means that they are minimums or maximums. Now it's pretty clear that this is a minimum, this is a maximum, but how do we check it? Well, if we take -1 and plug it into here, we get a negative number out. So that means f double prime at -1 is negative, which means, oh, hang on, did I just say that right? Yeah, it's positive. And it's positive because we have a negative times a negative. Positive, there we go. Since it's positive, that means that we've got a minimum. And of course, if we check f double prime at +1, this becomes positive, this is negative, so the whole thing is negative, and so we get a local maximum. Now we also should check to see if there's an inflection point. Well, when is this guy 0? So when is f double prime of x equal to 0? So this is like part 4 here. So this guy right here, f double prime, when is it 0? It's 0 when 2x times x squared minus 3 is equal to 0. Or in other words, 2x times x plus the square root of 3 times x minus the square root of 3 is equal to 0. So when does this happen? Well, when x is 0, when x is negative square root of 3, and when x is positive square root of 3. So possible points of inflection are these guys. But now we should look at f triple prime, okay, to see what's going on there. Okay, so f triple prime, it's a long mess what f triple prime is going to be. Okay, so maybe we don't actually have to take a look at that. And the reason I'm saying that we don't have to take a look at f triple prime is if we take a look here, it is probably the case that, well, actually, let's check this out. Hang on. Yeah, this guy comes out to be really complicated. So what we can do is we can take a look at these guys, and if we look to the left and the right of them and see what happens with the function, okay, whether it's positive or negative, we can look at the concavity. So to the left of negative square root of 3, okay, to the left of that guy, let's say at, like, I don't know, negative 2. Even worse than that, we can go all the way up. Well, negative 2 is good. So if we go to negative 2, and we plugged in negative 2 here, we would get a negative times a positive. So this would be negative. So here, f double prime at negative square root of 3 is negative. And since this guy is negative, that means that we must be concave up. So we know that where negative 2 is, we're concave, this is concave up, okay? And so this looks like this is all going to be concave up here. But now, yeah, excuse me, I said that wrong. So since the second derivative is negative, that means that we're concave down, which means we'd be at the top. So from here over, it's concave down. Then if we test it between here, we'd end up with concave up, and then concave down, and then concave up back here at those inflection points. So negative square root of 3, positive square root of 3, and also 0 is another point of inflection. And again, we've got this symmetry involved here, so you can tell that this is what the shape of the graph looks like.